Ladies and gentlemen, this is a video that's going to give you the solution for our most recent two-dimensional accelerated motion quiz. And the question you had on the quiz would have read something along the lines of this. A speedboat is moving at 6.4 meters per second west, 35 degrees north, when it starts accelerating at 2.2 meters per second squared south for 4 seconds. And you are asked then to calculate the final velocity. Okay, so let's start by writing out some givens, and our givens are 6.4 meters per second, and that was west 35 degrees north, and that was equal to v1. The acceleration is also given there at 2.2 meters per second squared, and that had a direction of south, and that was equal to our acceleration. Please make sure you put the vector hats on here so you know that these are vectors, because it's pretty important. And finally, this all occurred over a period of 4.0 seconds, and that was therefore our time. The unknown that we had in this equation was what is v2? So our unknown here is what is v2? And you can see by looking at these variables, the only way that we're ever going to associate these variables together is with the equation A is equal to v2 minus v1 all over t. Okay, and with some rearranging, I'm pretty sure that everybody can understand that if we have a times t plus v1, we will have v2. Okay, so we're looking for v2. A times t plus v1 will give us that. Okay, so I've just erased the equation we came up with, because I think that you can follow along with me if you've written that down. So what we need to have is a times t, and a times t is equal to 8.8 meters per second, and that is in a southerly direction. And our equation that you've written down says that we need a times t plus v1. But those are in two different directions. This is south, and v1 is west 35 degrees north. So we know, because they're vectors, that we're going to have to draw a diagram of it. So let's start with that. Here's a times t, if I can draw it in a fairly straight southerly direction. So this is a times t, and some of you know that this is also called delta v. A times t, and that equals 8.8 meters per second. And the equation that you have written down in front of you that I just erased says we have to add v1 to that. So let's add v1 right there, okay? And v1 was 6.4. So we know that this has a magnitude of 8.8 meters per second, and this has a magnitude of 6.4 meters per second, and let's label that as v1. And we know that that v1 had an angle off the westerly axis of 35 degrees. And if that angle was 35 degrees and our AT vector was due south, we know then that this angle is 55 degrees, and that's an internal angle. And if we then find the resultant vector of these, which I'll do in red here, and not a particularly great diagram, we know that this is going to give us v2. And if you look at the equation that you have, where it says a times t plus v1 gives us v2. Okay? And if you have done that, that's fantastic. And what you'll see now is you have a magnitude here and a magnitude here, and you have an internal angle. Having done that, we can now use our cosine law. And by using cosine law, we can solve for v2. And cosine law says that v2 is equal to, see if I can fit it in on this screen here, it'll equal 8.8 squared plus 6.4 squared minus 2 times 8.8 times 6.4 times cos of that internal angle, which is 55 degrees. And if you can use your calculator properly, you have to be careful about doing this. Some of you are having trouble with it. You get 7.33 meters per second. Okay, and that's great. But because this is a vector, which I should put the vector symbol on there, because it's a vector, we also know that we need a direction for this. So what we're going to do then is we're going to need to sketch ourselves a little compass row there, and it would be pretty great if we could find that angle right there. So why don't we use sine law for that, and we'll write down that sine 55 degrees divided by V2, which is 7.33 as calculated, equals sine, and let's call this theta, sine of theta divided by 6.4. And if you do that, you'll find that theta is equal to 46 degrees, which means that we can now determine that the second velocity is 7.33 meters per second south, 46 degrees west. And there's our answer.